Our first speaker is Bill Chen, and Bill is an ASE Fellow and Senior Technical Advisor at ASE Group. Prior to joining ASE, he was the Director at the Institute of Materials Research and Engineering in Singapore, following a distinguished career at IBM. Bill's a past president of the IEEE Electronics Packaging Society and has been elected a Life Fellow of IEEE and a Fellow of ASME. So thank you, Bill.
Thank you, Greg, for your gracious introduction. And I want to thank HIR and MEPTEC for organizing this very important workshop. The talk that I'm giving today is called Chiplets and the HIR Village. HIR stands for Heterogeneous Integration Roadmap. I want to acknowledge my colleagues, Ravi Mahajan and Bill Bottoms, and particularly the Heterogeneous Integration Roadmap Technical Working Group teams. They are the people that does the work, and it's very important that we acknowledge all of the work going on. Next slide, please. So I will speak about COVID-19 and the digital transformation, coming to the end of technology scaling. And then I will speak about Heterogeneous Integration Roadmap and why it is important to have chiplets and the HIR Village. And then give some examples of innovation bubbling up everywhere today. Then I will summarize. Next slide, please. As we go through the pandemic, we are seeing millions of infections and staggering loss of life, heroism, sacrifice, and resilience. Important to recognize that this tremendous global collaboration of vaccine science, of vaccine deployment, these are examples of collaboration globally, volunteer across all the different scientific institutions. It's an example for us to see how collaboration works, and collaboration can really be important to advance science, advance technology. With the Delta COVID surging, we hope for this rapid growth of vaccination. We're optimistic. I'm sure HIR will be to have a meeting face-to-face all together in a not far distant future. Next slide, please. So I will just give an example of the changing of our technical landscape today. This slide at the left is 2006. Next slide, please. The 2006, you could see that the top 10 public companies by market capitalization. There's only one company that is called Microsoft. That is what we call today as the tech companies. Click, please. And then if we go to 2020, December, you could see that the top 9 companies by public market capitalization, they are all tech companies: Apple, Microsoft, Amazon. And you go all the way down, you could see Tesla, Alibaba, and TSMC. Why is that so? Because the market value, the tech companies, because of the digital transformation that we are seeing. Click, please. So technical companies, they are leading the digital transformation of the global economy and fueling the artificial intelligence, machine learning revolution. Of course, the COVID lockdown actually greatly accelerated this transformation, this digital transformation. Next slide, please. So this is a presentation by John Hennessy. John Hennessy is the chairman of Alphabet, and many of you know him as the president of Stanford University, and also, of course, the book that he authored on computer design. So he presented at the DARPA EIR conference, July 23rd, 2018. What he showed is that the performance of the computing is greatly slowing down. You see the rate of performance from 1986 to 2003, 52% a year. Slow down, slow down, slow down, almost flat today. Click, please. So the progress in processor performance has slowed. The presentation, the talk that he gave at the DARPA HIR conference, after he shown that, he went and said that this is the golden age of application-specific architecture. And so this very much in line with what we are speaking in terms of the chiplets today. He said this will be the golden age of the designers. Next slide, please. And another presentation by Lisa Su at the DARPA HIR conference, this time on July 15, 2019. She is showing the Moore's law economics meeting headwinds. And she is, in that conference, she presented the product that AMD is doing on EPYC second generation. Of course, the time when she was presenting the EPYC second generation was not announced. So she went through much of what is going on. But later on, I will show you some more the details of this, of the material given by Brian Black later on in the presentation. Thank you very much. Next slide, please. So this is the presentation by John Schaff at the Lawrence Berkeley National Lab. And she is saying that the exascale supercomputer performance, they are all flattening. And she asked a question, then what? What do we do after 2021? Click, please. So she is seeing all this flattening, and in that presentation that he, click, please, in the presentation that he presented at the HIR conference on February 24th this year, he was saying is that the supercomputer need to be designed specifically for what it does, and not a general purpose supercomputer. So we are really going into a time of application-specific computing. Next slide, please. So just a few words on technology roadmap. 1991, world's first open source technology roadmap, NTRS, National Technology Roadmap for Semiconductors. 1991, and then 1998, the Europe, Japan, Taiwan, and Korea joined. So that is renamed ITRS, International Technology Roadmap for Semiconductors. 2014, benefit of Moore's law scaling diminished, and decision was made to end ITRS. The last edition of ITRS was published July the 8th, and you can still download that from the SIA website. Next slide, please. So the Heterogeneous Integration Roadmap is sponsored by 3 IEEE societies: Electronic Packaging Society, Electronic Devices Society, Photonics, together with SEMI and ASME, Electronic and Photonics Packaging Division. They cover comprehensively the microelectronic technology ecosystem. In that roadmap, we articulate the state-of-the-art advances in technology and science. I'm talking about future directions. And it is really a knowledge roadmap and knowledge supply chain for the heterogeneous future. And you can download that. It's about 590 pages, and it's just download free, no charge, at the EPS website. Next slide, please. I'll just read very quickly the IEEE press release when this roadmap was released on October the 10th, 2019. It said that the roadmap is a roadmap to the future of electronics, identifying technology requirements and potential solutions. Very important, primary objective is to stimulate pre-competitive collaboration among industry, academia, and government, research institutes, so that we can accelerate progress. We offer professionals, people like you, Denise, and industry and academia, a comprehensive strategic forecast of technology over the next 15 years. For devices and materials, it's 25 years projection. Next slide, please. So that is the definition of heterogeneous integration. Would you click, please? So you have die 1 from Fab 1, die 2 from Fab 2, maybe some of the MEMS, filters, etc. And they are integration of separate and manufactured components into higher level assembly, provides enhanced functionality and improved operational characteristics. Next slide, please. So I'll just go back to the paper of by Dr. Gordon Moore back in 1965. And I would just show you that in his paper, he talked about the product that we are going to make from electronics. He said the total cost of making a particular system must be minimized. We could amortize the engineering level of over several identical items or evolve flexible techniques for the engineering a large function so that no disproportionate expense need to be borne by a particular array. That other paragraph is specifically addressed to what we are speaking about. It may be proved to be more economical to build large systems out of small functions which are separately packaged and interconnected. Availability of large functions combined with functional design and construction should allow the manufacturer of large systems to design and construct a considerable variety of equipment, both rapidly and economically. It's really a visionary message. Click, please. So now if we look at chiplets, chiplets is part of the system functional circuit block, like SLC, designed to communicate with other chiplets through specific die-to-die interface. Following what Dr. Gordon Moore said, the goal is to manufacture each chiplet economically for optimum cost and performance for the integrated electronic system or subsystems. What we are speaking today on chiplets really goes back to what Gordon Moore talked about back in 1965 when he wrote that visionary paper that we all consider to be more slow today. Next slide, please. So the HIR Village from Wikipedia is that it takes a village to raise a child. It means that an entire community of people must provide for and interact positively with the children for those children to grow and thrive in a safe and healthy environment. The HIR Village then is a community comprising of engineers and scientists that voluntarily come together, like what we are for Heterogeneous Integration Roadmap. It is a global village of like-minded people from across diverse disciplines, multidisciplinaries, that we need in our industry. We who all share this common vision of maintaining progress for the heterogeneous future for the common good. Next slide, please. Click, please. So it is an application-driven roadmap. So first, we talked about the market. We have 6 identified markets applications: high-performance computing, data centers, mobile, medical and health and wearables, automotive, IoT, aerospace, defense. Click, please. Then we had the building blocks. We have the building block of components. So we have technical working groups, chapters on single chip, multi-chip, which include substrates. And then integrated photonics, integrated power electronics, MEMS and sensor integration, 5G communication device, beyond. So each of those are different chapters. Then we have the cross-cutting technologies, materials, emerging devices, test, supply chain, security and thermal management, and reliability. I think we will have a speaker on reliability today. Next, click, please. Then we have integration process, SIP, 2D, 3D, wafer level packaging. But for chiplets, really, really important is co-design and simulation. How do we do co-design between the different, what I would call silos? How do we do co-design across our industry between the IDMs, the fabless, system, packaging, all of this co-design simulation, very, very important. Next slide, please. For example, if we have automotive, we talk about the HIR Village. If we have automotive questions, then what are the people who's involved? Single chip, multi-chip integration, technical working group, power electronics, MEMS and sensor integration, 5G communication, beyond communicate between the vehicles. Then we have materials, supply chain. Many of the people are made aware of the importance of supply chain for automotive just in the last few months. Then reliability, high reliability for automotive importance. SIP, wafer level packaging. I mentioned co-design and simulation again. Next slide, please. But if we look at high performance computing, we have more or less the same set of characters, but you could see that we are a little bit different. Just like we have integrated photonics becomes very important. Power and electronics becomes very important in a different way. We have 2D and 3D interconnect, wafer level packaging, again, co-design, but then test. Chiplets needs test, security, thermal management. So these are the people who are at the first line defense. And then with the second line defense coming in are the other technical working groups. So altogether, as I mentioned earlier, we have 23 different chapters. And all the different chapters, they work interactive with each other, looking at the same thing through different lenses. Our goal is that the value of the total roadmap, the 23 chapters, is greater than the sum of the individual. Very important. We are not siloed. We work together across the different technical working groups. Next slide, please. So there's an important slide that's coming out from Professor Mitra, coming out from Professor Wang at Stanford University. He said that during the time of Moore's law, the single focus is miniaturization toward the next set of nodes. As we emerge from miniaturization tunnel, opportunities for research, outlook, innovation becomes infinitely brighter and broader. And then she showed this slide of this person walking out of the tunnel. This is exactly what's happening. We are at the end of Moore's law, or we are at the end of the scaling. And we are looking at all the different ways, and chiplets is one of the areas that we could see tremendous amount of innovation that is being developed. Thank you. Next slide, please. So innovation bubbling everywhere, and we just show some of the examples of the innovation bubbling. Next slide, please. So one of the areas that's important for us is the DARPA CHIPS program. You could see that this is DARPA's chip programs enables rapid integration of functional blocks at the chip level. You have custom chiplets, commercial chiplets. How do they work together? That is an important DARPA program for the military and aerospace market. Next slide, please. So this is an example of integration antenna modules. This you could see that it's on the right is the Samsung Galaxy S10 5G antenna modules. On the left is the iPhone 12. So we have a new product that came out to the market that is driven by 5G antenna modules. Next slide, please. And these examples I mentioned previously about Lisa Su's presentation. So this is Dr. Brian Black's presentation at IMAPS, October 5th last year. What he showed is the multi-chip modules, and then in 2017, that is homogeneous integration. That in that case, what they have is they made the die smaller, and so that they could get better yield. And in the 2019, the one that I mentioned earlier about Lisa Su's presentation is the chiplets. What you could see in the middle is the IO die, while on the left and right, the small die, they are the 7 nanometers. They are the 7 nanometers compute, what they call a compute die. What they showed is that at the right-hand side, what Brian Black showed is that the traditional monolithic compared to the first generation EPIC homogeneous integration, they got a 41% improvement. That is to say that the cost on the right is 0.59x on the left. So they enjoy the yield. Next slide, please. But you could see that on the bottom is that using the chiplet approach, the 7 nanometer compute, they got tremendous improvement in terms of the performance and the cost. And then on the right, you could see that they could have a flexibility of different costs, and so that it help in the marketplace of different kind of products that you can ship. And in each case, you could see the hypothetical cost reduction. Next slide, please. This example from chiplets from Intel, and the source of that is presentation by Ravi Mahajan that shows the EMIB, Favoris, and co-EMIB. And as we all know that in each of those, Intel has shipped significant amount of product into the marketplace. Next slide, please. This example of fan-out chip on substrates, and this you could see example of 2 die on a reconstituted wafer, and this provides multiple products, chiplets-like, in the volume production since January of 2016. Next slide, please. Another example of the chiplet approach, of course, is the 2.5D, and with HBM on the side of the main processor. It shows a line space on the silicon 2.5D interposer, and that is line space 0.5, and then also show the 2.5D high bandwidth memory. So we have different solutions, many solutions that accommodate the chiplet revolution. Next slide, please. Silicon photonics, very, very important. That's also a presentation by John Schaff at Lawrence Berkeley National Lab. And he shows schematically how the co-packaging is an important part of the chiplet revolution. Next slide, please. So in summary, we are at a unique time when the global convergence of technology chaos and business disruption joined by COVID-19 pandemic. There's really immense need for this pre-competitive technology roadmap so that we can address the future vision, different challenges, and potential solutions. Chiplets is a powerful technology direction for systems integration. And the HIR Village is a truly global village, as I mentioned earlier, like-minded people across diverse disciplines coming together so that we could maintain the progress of heterogeneous future for the common good. Next slide. I think we are, okay, I just want to quote President John Kennedy. We choose to go to the moon this decade and do other things, not because they are easy, because they are hard. Because the goal was serve to organize and measure the best of our energies and skills. Because the challenge is one we are willing to accept, one we are unwilling to postpone, and one which we intend to win, and others too. And I think that applies to what we are seeing today. We see many challenges for Chiplets, but these are the challenges we are willing to accept because this is important for us to go forward. Thank you very much. Any questions?
Yes, thank you, Bill. If you have questions, please use the Q&A link at the bottom of your screen. And Ira, thank you.
No questions?
Okay.
Actually, I have a question for you, Bill. With the chiplets, obviously, and the HIR roadmap is looking at the challenges. Do you see other organizations leading in standardization? I know we have people who will talk about standards later in today's program, but what role do you think the HIR teams will play in driving or formation of standards or identification of standards needed?
The way that HR is doing is we are participating with the different groups that are working on the standards or working on the preparation of the standards. I think what we bring to the table is the input from the various different groups. For example, I think one of the questions many people ask is test. And you know, I know that the HR test technical working group has been active in discussion of the question of test in the quote unquote standards. And the HR chapter that has the highest amount of chiplet discussion is in the high performance computing and data centers, because that's an area that the major application is coming in today. And I could see in the future, there will be in the mobile area, in the 5G area, and perhaps in the automotive area in a not too distant future. So yes, the answer is we are participating.
Thank you. Yes, we've picked up quite a few questions now. The first question that came up is, what bottlenecks do you see for co-packaging optics, and where's the biggest market for co-packaged optics?
Co-packaging optics has been talked about by many people, and many people said that it is going on right now. My own feeling about it is that it is going on in the different companies, and because it is active in the different companies, so it is not being published. And but co-packaging directly in optics is a essential part of our progress, particularly in the high performance data centers, where the energy use is so very important. By the way, I did not mention that specifically in the case in the AMD presentation, they specifically mentioned that energy reduction is a very important part of their matrix. And I think optics definitely will solve a significant amount of the problem.
Thank you, Bill. It's 8:35. Did we want to switch to the next speaker, or
why don't we do one or two more questions?
Okay. Beyond the roadmap work, Bill, what do you see as the greatest need for collaboration for mutual interests for the hybrid integration roadmap?
Well, what I see in this is that we need to. So I just want to speak about what I can see important for the roadmap. We would like the roadmap to be used by the funding agencies, so that they could use that as help them as a vision on funding the future of our profession. One of the very important part of what we have today is not just technology. It is the future supply chain of the talent of the talents of scientists and technologists, engineers that will come into our profession. We may have people said, "Oh, we will," just like the U.S. government saying we were going to put $55 billion. Important part of that is that we need people that has talent. And I see the roadmap is providing the materials. The roadmap is providing the areas of important research topics that would stimulate the research in universities, thesis research, and great interest of all of the people of these talent pool. I think the talent pool for the future is a major challenge for us. And I will say that we did not say that in the specific roadmap, but it will be well discussed in the 2021 roadmap.
Okay.
So people, talented people, that's what we need.
The next generation.
The next generation going out and be enthusiastic, be happy, and Ira, you'll still be there to host the chiplet revolution 15, 20 years from now, right?
Right. We can continue to host the revolution like we are for the known good die. So yeah. It's an important topic that will continue for quite some time. Yes.
Yeah. And fairly simple question, what distinguishes chiplets from the bare die of the MCM era?
Well, I think there are a number of different things. I think in chiplets, as I define it in that word that we have, is that it's just it's a design with specific directions, design with specific goals, design with specific understanding of the the very important die-to-die interface, so that you can have high bandwidth and minimize energy. And I think chiplets sets a direction that previously we do not have.
Thank you, Bill.
Okay.
Well, thank you very much for the opportunity. It's a wonderful thing that you are doing. Thank you.
Lastly, I'd like to thank once again our sponsors, Advantest, Amcor, and Synopsys, who made this event possible. Advantest rated the best ATE company 2021 in the VLSI Research Supplier Survey for customer satisfaction. Amcor leading OSAT with differentiators in technology, quality, and services. And Synopsys providing solutions from silicon to software. So I thank them. I thank all of you for attending, and look forward to seeing you at a future MEPTEC event soon in person, but we'll also continue the virtual format because it's great to have such a wide variety of speakers and attendees. So thank you all and have a good rest of your day.